So what we're going to do is Rick's got a 10K Type 3 temperature sensor, Type 3?
Type 3.
Okay. And that will be installed with that air handler eventually.
So once the plenum
it's there.
takeoff goes in, we're
Right.
going to have that sensor in, and that's going back to the assembly of the wall behind Rick.
Right. So today Rick is going to act as the ductwork and
Good job,
hold
Rick.
that in place. And what we have done is we've wired it back to the thermal energy meter that's here. That's a Measurement Canada certified thermal energy meter. And that has the ability to take an additional input. So one of the great use cases for that is taking a passive temperature sensor back from the supply air of the ductwork that perhaps that system serves.
So in this case, we can actually see from the PCM battery how many BTUs are we delivering to the air handler. We can also see the temperature at the air handler, which is pretty cool.
Right.
So we can see whether we're getting what I would call usable heat.
Exactly. Because it's supposed to be all about comfort. Are we delivering comfort at a rate that the comfort should
For
be,
sure.
Right.
Yeah, awesome.
Exactly.
And just like everything else, right? You can't control what you don't measure. So
100%.
absolutely, let's add that.
That's
So-
why it's Measurement Canada certified, so it's not DJ, Rick, and Mike said to work.
All right.
Exactly. So I've already logged into the thermal energy meter. I'm going to go into the settings tab here, or the settings menu, and go to application. Now the application comes up and I'm able to set some other stuff up. So this setting here will change how that thermal or that temperature sensor operates, but it won't affect the existing commissioning on the meter itself.
Right.
Because it's Measurement Canada certified, that meter commissioning is done once
Never done
and
it.
never done again.
Yeah.
Because any changes after the fact would affect the certification of it.
Right, so if we look at a real world application for that, we're using that for testing, but if we were putting this in a high rise building, you're going to be billing from that. So you definitely want to make sure nobody's able to mess with that.
On either
Absolutely.
side, either the owner of the building or the tenant in the
Yeah.
space, neither party needs to have the ability to tamper with it.
For
right?
sure,
So it's
yeah.
all fair and equal.
Yep.
Okay.
And to that note, we have variants of this that are not Measurement Canada certified. They have the same testing and the same specification. However, the certified meter register isn't available in the non-Measurement Canada certified version versus this one.
But the non-Measurement Canada one is just as accurate and will tell you your glycol percentage, which is really
Correct.
cool.
Absolutely.
Yeah.
It'll compensate for that glycol.
Okay. So where I'm going is I'm going to this tab this sub menu that says additional meter settings. I'm going to pull down this menu and I've got three options: active volt, passive, or switch. And because this is a passive sensor, it's a 10K Type 3 thermistor, I will choose passive. And in a moment, I should see a second one. So it says resistive measurement. So I've got options for PT1000, NI1000, NTC Type 2, or 10K Type 3. So I'm going to use 10K Type 3 because that's what we have.
Yeah, and it's important for people to realize that's not an option. If you specify the wrong sensor type, you're not going to get accurate readings.
Exactly. So
So, for example, if it said it's 1,000 degrees right now where Rick is standing, we know we've picked the wrong sensor.
Yeah.
right.
Yeah.
And you, Mike, are you a Fahrenheit
I am a
supporter?
Fahrenheit guy.
I'm sorry to hear that. We will go
Didn't
over
you say
here
those
to-
are freedom units
They are
earlier?
freedom units, yeah.
We could give you Kelvin or Rankine, whichever one you choose you'd like.
Robert
Right.
Bean would like Kelvin.
Yes. yes.
Okay, so this actually, the funny part is the back end of this device
Kelvin.
is Kelvin. So
Yeah.
every measurement is done in Kelvin.
Well, that's how
And
it should be measured, right? But as
We're
late
referencing an absolute is what
Yeah.
we try to reference.
Exactly. So it's converted to Fahrenheit or Celsius as required. So now that we've got it set up, it was quick, it was easy, and it's now done. We can look over here at the main screen where it's telling us what the inlet and the outlet temperatures are. You've got it on the return of supply. You've got it on the...
it's on the outlet side, so that would be on the supply.
All right. And now we've got down here the sensor value. So Rick holding it with his hand, it's looking at about 79.8 degrees. Blowing on it, it may take a minute for that to change, but it is rising. It's above 80, 82. So we have a pretty good
Right,
quick
so if
response
we
on that.
look at what we're measuring here, so this is feeding into the PCM battery. This is coming out of the PCM battery. To be clear, this PCM battery has not been charged in 2 weeks and it's still almost 80 degrees, right? So obviously not usable heat. And the sensor that Rick has in his hand until the plenum gets installed, it will tell us, okay, if we're putting out 120 degrees, it doesn't matter what's going through the coil. We care about the BTUs through the coil, but what are we delivering to the space?
Correct.
Because what we're trying to do is here and in my own home where we have the other lab where Belimo has products, is figuring out what is the ideal temperature with the highest possible COP that we can deliver usable heat off the area.
Right.
And having Measurement Canada meters is great because we don't want it to be, well, DJ and Mike said it felt pretty good. It felt reasonably comfortable. No, we need to be able to tell, yeah, lick your finger and hold it up, or be able to tell Robert or Siggy or Dr. Bills when he's here in May, this is the data. And the fact it collects 13 months of data, it's fantastic.
Yeah, I mean, the other interesting piece that you might explore is because it is one of our IoT products, really, you know, you were going to Italy in March, you could log into your meter at home through our cloud and say, well, but this is what my system is doing. It's right here, right? You don't even have to be there in the same country to see it.
So I have a question that relates back to this. So your valves, you were talking earlier about the valves. Do the valves also take any sort of communication signal or no?
The energy valves.
The energy valves do those little valves. Those little valves are meant to be more simplified.
Gotcha.
There is a version that we have in the US that has what DJ talked about before about our communication language called MP.
Yeah.
We haven't brought a lot of those here to North America. The cool thing we'd like to see them do is, so this manifold that you have here, in Europe we have a flow meter.
Yeah.
It's a smart flow meter like that energy valve that connects onto the header. And then off these different ports for your zones, we put a Belimo zone valve that's MP. What that allows us to do is the meter is the master, and the valves are all slaves to that master.
Yeah.
So what we do is we run a sequence that the meter starts. Press the sequence, and each valve opens. Have the pump running, each valve opens independently and then closes. The meter remembers each zone's flow. So it knows, okay, this is 2.6, this is 2.8, this is 3.1, this is 1.9. So it can balance the whole system dynamically because it has a measurement value for flow and a valve position.
Yeah, that's very cool.
It is very cool, right? But we haven't had a lot of adoption of that in North America, but a company like yours might be somebody who would be interested.
We just keep coming up with new ways to repipe this. We already talked about we've repiped this thing like a dozen times, 2 times in the last month.
Yes.
And yeah, now we're going to do it again.
Yeah.
But that's the point. It's fun.